Today we're going to talk about three people: Brahmagupta. Okay, so Brahmagupta around 650 invented the second degree polynomial expression. Al-Khwarizmi around 750 expression. So why we are talking about second degree polynomial is because 1590 when a 26-year-old man drove two spears, light and heavy, from the Leaning Tower at University of Pisa to understand the behavior of falling body, to understand the properties, three properties of the falling body, how the falling body displays with respect to time, how the velocity changes with respect to time, and how the acceleration changes with respect to the time. So he realized that the falling body displays, the displacement of a falling body is second degree polynomial quadratic, and this is how he arrived at the conclusion. So his hypothesis was d is proportional to t squared of a falling body. So displacement is proportional to the square of time. Now, how did you know that whether it is, what is it? The d is what it is, what is the value over here? So he went through a mathematical deduction. He deduced that this is in fact negative 4.9, negative 4.9. So negative 4.9. How did you do that? This is what I'll show you now. So when you drop something, you can measure that. At the 0 second, it will displace 0 meter. At 1 second, it will displace negative 4.9. That's how much it displays. You can measure that. At 2 second, negative 9. At 2 second, I guess negative 19.6. And 3 second, that's enough, I guess. We need only 3 point. So second degree polynomial invented by Brahmagupta look like ax squared plus bx plus c. So we're going to call this one x and this one y. That means the displacement is the time is x and the displacement is y. If that's so, then y is 0 is equal to x is also 0. So c is equal to 0. So we know a value of a second degree polynomial, at least the value of the constant. So c is equal to 0. We're gonna put it over there. Now let's keep going. Let's keep doing the mathematical deduction. Now this time the y is negative 4.9 is equal to, if y is negative 4.9, x is 1. And c is 0. So a plus b is equal to negative 4.9. We're going to put it. All right. We're going to keep doing because we have one more point. Y is equal to ax squared plus bx plus c. This time our y is negative 19.6 and our x is 2, and c is, we already know that, 0. So you have 4a plus 2b is equal to negative 19.6. So we're going to write it 4a plus 2b is equal to negative 19.6. Now we want to find, our goal is to find the value of a. Why we want to know? Because y is ax square plus bx plus c. We already know c. Okay, our final goal from here, from second degree polynomial, we want to write the behavior of a falling body. This is the math was available in 1590 during the time of Galileo, because it was discovered by Brahmagupta and proved by Al-Khwarizmi in Baghdad. Brahmagupta 650 in India and Al-Khwarizmi 850 in Baghdad. Right, so let's write it down. Let's write this one. A plus b is equal to negative 4.9 and 4a plus 2b is equal to negative 19.6. Let's multiply this one by negative 4 and this one by 1. If you do that, what do you get? This one gonna become negative 4a minus 4b is equal to 4.9 times 4 is positive 19.6. And this one, if I multiply by 1, is gonna be exactly same. 4a plus 2b is equal to negative 19.6. Cancel, negative 2b is equal to 0. So b is equal to 0. Alright, voila. We know that b is equal to 0. So now y equal to ax squared, that's what survived. Now we have to know what is a. So we know b is 0 and c is 0. So we know what is a. So let's take this. A plus b is negative 4.9. So a is negative 4.9. Okay, so we now know a because that's what we wanted to know. Negative 4.9 x squared. Okay. Now let's invade the mind of Galileo. Let's say the year is 1590. Okay, so let's write the displacement equation for a falling body. So I'm going to write down y as displacement with respect to the time. So here's the time, which is quadratic, second degree polynomial. And now the gravity is, I know that on the earth is negative 9.8 is given. Negative 9.8. So then what I have to put over here so that both of them become, when you put them together, become negative 4.9, half. So you have to put half, not 1/3, not 1/4, not any other number, exactly half. This is how he did this formula. D is equal to half at square. This is the simplified version. Thank you for watching.